You will very quickly find the computer one of the most useful and time-saving features on the Kenyon tunnel frame. Once a standard operating procedure, an SOP, for a given fabric has been entered into the computer as a production recipe, you will be able to simply call up that recipe at any time in the future when you want to run that specific fabric or any fabric under those specific conditions. This will eliminate the need to re-enter the operational data into the computer. And should you have microspeed 196 controls on your frame, you will not have to manually enter data on them. Not all Kenyon tunnel frames will have manual controls, but they will have the emergency stop, normal stop, start, and run speed buttons, plus necessary toggle switches. Even though you may have a touch screen monitor, we will use the mouse and its arrow to help you follow our actions better. Now let's take a look at how the computer works on the Kenyon tunnel frame. When you begin your shift, you will find a picture similar to this on your computer screen. As you look at this screen, you will see a number of different devices in the yellow area. Let me emphasize at this point that your machine and its controls may be configured differently. The devices may be located at different places on the screens. You may have more or less fans than we do here. You may have a different number of widths, or less or more motors. What you need to know is that it is okay if your screen does not look exactly like this one, but your computer screen and devices will work the same way as this screen. Let's stop here for a brief overview of the entire screen, and then we will zoom in on the various sections of the screen so you can see them real well. At the top of the screen is a title bar. It says Kenyon Tunnel Control Production. Next is a menu bar. Then we have a toolbar with buttons on it. The large yellow section of the screen contains all of the controls which are used on our tunnel frame. Air temperatures, fabric temperatures, widths, speeds, and so forth. At the bottom of the screen is the Adjust Set Point box, where you can set the amount of a change you wish to make. At the very bottom is an information bar. At this point, we will zoom in on the upper left-hand corner of the screen, and after that, we will zoom in on the upper right-hand corner, then the lower left-hand corner, and the lower right-hand corner. In the upper left-hand corner, we see this picture. In the title bar, we see Kenyon Tunnel Control Production, page 1. The tunnel frame illustrated here is not so large that we need more than one page to show all of the devices. Below the title bar, we have a small menu bar. First is File, which you can execute by left-clicking once on the mouse. First is the Open Recipe, which you use to open another recipe. Second is a Print a Snapshot. If you're in production and you have opened a recipe, you can print a snapshot of the current conditions. You also use this to exit the program, and this is not something that you will likely do. Next is the window menu. If we had more than one page, you could cascade the pages or you could tile them. Next is the help menu. There are help topics here which can be used while the tunnel frame continues to operate. This item is about New Prod 1, and it is copyrighted material about the Kenyon tunnel frame controls. Below the menu bar is the toolbar. The number of buttons on this toolbar may vary, and that's okay too. As you see, when you put the mouse arrow over one of the buttons, a small window pops up and it tells you what that button is used for. This one is for opening recipes. Next, you can print a snapshot. You can type in a new lot number. The fork, knife, and spoon are for recipe maintenance. The lock and key is for security maintenance. The handshaking is a communications test, so the computer can test the communications link to all of the devices before going into production. You can turn the data logging on or off with this button. This is another help button, which is very special. If you left-click the mouse on it, it will give you a little arrow with a question mark. When you drag it to the place that you want to ask a question about, then left-click the mouse for help. Notice that 3 of the buttons, the print snapshot, the new lot number, and the data logging, are grayed. Those stay grayed when you are not in production. We have not yet opened up a recipe, so these functions are not available. Now let's move into the control area of the machine. Notice that we have divided the fans into 4 sections, and the top fans are in this top row. The first blocks under the top fans are for the actual fan speeds. Right now, these blocks show control. That means that we are in control of this device. If this was a device that we were just monitoring, the word monitor would appear where you see the word control. The next line of blocks is where the set point values go. The set points are kept in the recipe. When you open up a recipe, the computer will transmit all of the set points to all of the devices. That is how the devices know where they are to be set. The next section is for the bottom fans for zones 1 through 4. Again, you may have more fans on your tenor frame, and they would show here also. Note that the bottom fans have an actual row and a set point row, just like the top fans. This example of the tenor frame has 2 exhaust fans, each with an actual and a set point block. Along the lower edge of the screen are width screws 1, width screw 2, and so forth. But we're unable to read the boxes. We will zoom in on these later. At this point, we will zoom in on the upper right-hand corner of the screen. The top line shows that this system is still separated into zones 1, 2, 3, and 4. Here we show the air temperature for each zone. Once again, the upper row is for the actual value, and the lower row is for the set point values. The second row of devices is for the fabric temperature, the surface temperature of the fabric for each zone. The top row, once again, is for the actual value, and the bottom row is for the set point values. Now we can zoom in to the lower left section of the screen. Now you can see those width screws. Number 1, 2, 3, 4, 5, 6, and 7. Here we have boxes for the actual values that the device is currently running at. And below that row, we have the set point values row of boxes. This particular tenor frame has a tenor motor, followed by a top overfeed and bottom overfeed motor, individual left pin on wheel and right pin on wheel, patter pull roll, and the patter. At the bottom of the screen is an information bar. Control means that this computer is the one that is actually doing the communicating with the devices. It does not mean that you must be at this computer to make changes in the system. In fact, you can be at either computer and make changes almost at the same time. Next, it says tenor, and the name of the tenor is Kenyon number 1. Adjust set points is not fully visible right now, so we will come back to it and show examples of how to use this section later. This is a close-up of the lower right-hand corner of the screen. Here are additional devices. Continuing with the motors is the rope conveyor, tenor conveyor, stripper roll, and the scrape feed. Above the motors are the Cisco data device, which measures the fabric width, a Marlowe device, which measures ounces per square yard of fabric, and the pad pressure. Cisco data, Marlowe, and pad pressure are monitored only. Some machines may have fabric temperature sensors. When furnished, they may be set up to monitor only or control and/or monitor. Again, remember that your tenor frame and therefore its computer screen may not look identical to this one. You may have optional devices not listed here, or you may not have some of the devices which are listed on this screen. Nevertheless, it will work the same way. Now let's look at the Adjust Set Point segment. Should you need to make set point changes, it will be done through using Adjust Set Point. You can make set point changes by 1/10, by the value of 1, by the value of 10, or the value of 100. When you decide how much you want to change a set point value, put the arrow over the value you want and press the left mouse button. Notice how the small dot has moved? Click on 10 or on 1 and the dot moves there. That's how you control the increments by which you will make the set point change. If you want to make a device go up by 1 as in the speed of the pattern, set the small black dot on Adjust Set Point value of 1, then move the arrow to the top box of the pattern, and you would left click 1 time, and that will make the speed go up by 1. If you want the pattern to go down in speed, you would simply move the arrow to the lower pattern box and click the mouse left button 1 time, and that will reduce the pattern speed by 1. All changes on all device set points work the same way. You will not be able to manually change values of the microspeed 196 processors or heat controls while the computer is in control. Now this does vary from company to company and from plant to plant, but as an operator, you may find that you will be limited in the values of changes that you can make, or the access to certain menu items or tools on the toolbar. This may be done, for example, in order to prevent those individuals who are not trained and experienced in the recipe management section of the computer from making changes which would damage the fabric. You will, however, have the ability to make minor adjustments to fine-tune the running conditions of your tenor frame. Limitations not only protect the fabric, but the operator as well. Any limitations placed on access to security-protected items is done for the sole purpose of enhancing the integrity of the program contents, and therefore reducing the possibility of error in running the tenor frame, which would result in the production of off-quality fabric. In fact, Kenyon recommends that management give strong consideration to limitations of access to such items as recipe maintenance and security maintenance. We will now demonstrate how to open a recipe and take the tenor frame controls into production. Move the mouse arrow to the Open Recipe button on the toolbar. Left-click on the mouse one time and up pops a recipe listing. This is a list of all of the current recipes that have been created for this specific tenor frame. At this time, you can either type in the number of the recipe that you would like to use, or you can move the arrow down and left-click on the one you would like to use. And it will automatically put it in the selection box. If you change your mind at any time, you can press Cancel to cancel this function. If the recipe that you choose is indeed the one that you want, you can move to the OK button and left-click one time to move to the next step in starting production. Let's zoom in on this box which just popped up. This is the Enter a New Lot Number box. The message says to type in an optional new lot number and press OK. The optional means optional to the Kenyon tenor frame software. Your plant may require that a lot number be entered for each and every lot. Let's hold it right here for a minute. Computer technology is changing so rapidly that systems may vary from this training tape. But each system will operate basically the same way. Although we are using a keyboard and mouse for our demonstrations, future systems will have the ability to call up on screen a number pad for entering lot numbers, and even an on-screen keyboard for use in recipe maintenance, thus eliminating the keyboard and mouse. We will type in the numbers 1, 2, 3, 4 as our lot number. Of course, you can cancel this by pressing the cancel button with your finger or the mouse. By pressing the OK button, we continue to the next step. What we will do at this point is zoom back out to the full screen so that you can see what it looks like as the set points are being transmitted. Notice the hourglass came up. In just a moment, you will see set points come up on the screen as you do here. These appear as each set point is transmitted to each device. It is done in a sequential manner, and it is only this computer that is in control which is doing the transmitting. Once all set points have been entered on the screen, the system will begin asking each device what its actual value is. What you will see on our screen, since this is a demonstration and we don't have enough devices to fill the screen out, is that you will see error in the actual value of a lot of the devices. What the error means is that this device did not communicate back with us. Therefore, error is proper. In your system, if we see error, we will have a problem and you will need to call maintenance. It will mean that the device is either not functioning or communicating, which is an indication of a problem. Notice that on some of our devices, motors in particular, which are not running, shows 0. We haven't pushed the start button yet. Thus, they show 0 for the speed, and that is correct. And that is how you start up a new recipe and take the system into production. At this time, when all other operating conditions exist, and you have checked with the rear operator to be sure they are ready, you can press the green start button on the front console. And once the machine is running, press the run speed button. Remember, you are in control of the computer, and the computer is in control of the Kenyon tenor frame.